Good afternoon to those who have signed in already. I'm just going to allow a few more moments for anyone else who's going to be joining us today to log on as well. Okay, we've had a few more people join us as well. I'm sure there'll be a few more additional people joining too. So I'll make a start. Um, Welcome everybody to the final Living Wind Farms project workshop from concept to deployment. My name is Jack Catamol. I am operations manager at Exo Engineering. Just wanted to check, can everybody see my screen and hear me okay?
Excellent.
Okay, fantastic. If I could just ask everyone to make sure their microphones are muted as well. There'll be multiple opportunities during the workshop for people to unmute and ask any questions. And please feel free, if you do have any questions, to just pop those in the chat as we go along. Just wanted to make people aware as well that this session is being recorded. So just to quickly run through what we'll be talking about today, we'll begin with a quick introduction to the Living Wind Farms project before I pass over to William, who will take us through the early TRL levels, covering the product development stages. Then we'll pass back to me, who will be going through the middle TRL stages in terms of design, manufacturing, and prototyping. Before we pass over to Sam, who will take us through the late TRL levels of the project. After that, we'll pass over to Tice from Total Energies to talk to us a bit about the lessons learnt regarding nature inclusive design and what comes next for the Netherlands. Then we'll go on to some of the results from the SWOT analysis that was conducted in the workshops in November before we finish off with an open discussion. We had planned to conduct a panel discussion as well towards the end of the workshop today, but unfortunately, some of the speakers are now unable to attend. So we thought what we'd do is present the results from the SWOT analysis and then open up the discussion. So to give a bit of an overview about the Living Wind Farms project, it was part funded by the Offshore Wind Growth Partnership and began in July 2022, just a few months before I joined Exo Engineering. It's due to finish the end of this month, January 2026. And over the course of the project, we've been able to develop a considerable network, including project partners, the Rich North Sea and Total Energies. So to go over a few of the aims of the project as well, we really wanted to be able to develop new exo-reef concepts in order to meet new markets and end user requirements, establish a number of pilot deployments of exo-reef scour protection at offshore sites, including developing long-term biodiversity monitoring campaigns, and also to conduct effective industry outreach in order to share scientific learnings. And I think this slide sums up the project quite nicely, just allowing us to zoom out and take a look at exactly what's been taking place over the course of the project. And many of these milestones will be explored in a bit more detail over the next few presentations. And we've been able to achieve the aims of the Living Wind Farms project by working through the technology readiness levels, or TRL levels for short, from researching low carbon materials, ensuring compatibility with conventional deployment methods, and engaging with stakeholders, through to prototyping, and design customization, and finally, undertaking pilot deployments in real-world settings. So just to make sure everyone's on the same page, we hosted 3 workshops in November, each of which was targeted at a different group of stakeholders. And these 3 groups were ecologists, contractors, and policymakers. And as part of these workshops, participants were invited to conduct a SWOT analysis of different nature-inclusive interventions which can be used within offshore wind farms. Now, I'm sure many of the attendees who were at the workshops in November are keen to hear about the results from the SWOT analysis. So before we begin to recap the project, I just wanted to go over some of the headline results from the SWOT analysis. So the kind of main thing that we picked up on was that almost everybody was in favour of nature inclusive design, but didn't think it should be mandatory as part of offshore wind developments. And we also noticed that scalability was mentioned by by all of the stakeholder groups as a strength of nature inclusive design, with decommissioning and invasive species consistently being mentioned as weaknesses. So that's it from me for now. I'm now going to hand over to William, who will be taking us right back to the beginning of the Living Windfarms project.
Hi, hi everyone. Am I sharing my screen now? Is that coming across okay? That's perfect.
Yes.
Right. My presentation will be on the early TRL, as I mentioned, and thanks everyone for attending this final workshop. We're all very excited about the talks we're delivering today. So we can probably spend quite a lot of time talking about success stories, and we talked about success stories in previous workshops. We have hours worth of exciting footage that we could share, and this is one example. I'll just play this short little video, and I'm just wondering from this little video, anybody kind of guess how many species we actually can spot in this footage? So this footage was 40 meters depth in the North Sea on our Exo Lodge artificial reef. Well, we encountered 64 species during the November survey, which is an amazing result, and we're very pleased with. But rather than basking in the success and what we've achieved, I would like to kind of share our journey and take you back to how this all begun, because the Living Windfarms project didn't start at TRL 1. It started a long time ago. So let's go back in time and see where we started. So just for a little bit of background, some information about TRL for those who are not completely familiar with it. There's a few different approaches, different kind of descriptions of each level. Doesn't really matter. It's a staged approach from 1 to 9. But you must be wondering, why on earth do we want to start talking about TRL? Because Exo develops products. The TRL stages or levels are obviously really easy to explain where we are, and it runs from basic principle to commercial product. Sorry. So in order to revisit the entire project, the TRL are easy to appraise the workflow. So there are several factors and market insights we'd like to share, and for that purpose, we've split the workshop in these TRLs. So I've got the pleasure of covering the early TRLs, whilst Jack and then Sam will cover later stages. So here we go. You've seen this one. I'm particularly focusing on the 4 subtopics here on the left-hand side, which include stakeholder engagement, species preferences, deployment methods, and low carbon and recycled materials. So we started off a long time before July 2022, before the Living Windfarms project. And particularly, we focused on 2 concepts, GeoBlock trademark and technologies, which developed our mixing blends, And secondly, the design criteria for reef development as researched. And in 2022, initial products like the hexagon reef and spheres were explored and tested. So I'll just delve into these in a little bit more detail. So we've carried out more than 8 years of blend development under the GeoBlock trademark, which includes studying carbon content, recycled content, beneficial use of dredge material, local or natural content, and a range of exotic binders, which then led into blend economics. Blend economics, or the economics of the mixed blend, was a critical aspect for appraisal as part of our growth path. As you can imagine, that some of the exotic or unique binders can be very expensive and did not always make it through to market. So from test cube to biocolonization trials, we spent years in appraising the options. This is a biocolonization trial carried out in Newlyn many years ago now. So for the hexagon reefs and spheres, we actually started early on looking at colonization, deployment methods, field trials in the east of England. We did this under our own marine license with elements on a timber frame, like in this picture. We experienced quite a few challenges. As you can see there, deployment was very time consuming. The items didn't naturally go through a full pipe or were limited in the scale of the project. And also the gains were quite limited size. So based on these experiments, we're able to further define targets and what the Living Windfarms project should have been focusing on. So this involved scaling up some solutions, whilst other solutions were focused on mass deployment. So that's another picture of that deployment. So the third aspect we looked into was stakeholder engagement or market research, and this was carried out in the shape of stakeholder engagement, interviews, workshops, and other interactions with offshore developers, contractors, ports and harbours, aquaculture, and also around coastal protection. It actually improved our understanding of the market and market demand, and in particular the current species and habitats that are focused on, such as Atlantic cod, subellaria, and native oysters. But it was also a criteria to look at the importance of health and safety, and especially around deployment. And finally, this market research told us about market demand, specifically around mixing blends and mix economics as well. So we've been talking about specific species and the target species, but this is only a small amount of species that is actually focused on by the wider market. And the habitats that we use as reference points, such as the baseline habitats, are possibly suboptimal due to the shifting baseline syndrome. So we do need to consider the shifting baseline syndrome when we develop the projects. But we found that there is no international consensus about marine baseline, for example, for the North Sea biodiversity across the bordering nations. So that's an element that we believe needs improvement when it comes down to restoration and nature inclusive designs. So how are we able to restore the marine environment without the regulated consensus across the borders? So this market research pointed out specific attention should go to the following criteria, in addition to the blend economics that we've mentioned. Habitat function, for example, and habitat features relate to offering of food and shelter for adults, eggs, or juveniles. The design needs to consider hydrodynamic stability, scour properties, and deployment in order to be successful. So we had all these criteria that allowed us to create and develop new products. So in July 2022, as part of the Living Wind Farms, we started further developing the exospheres and subsequently developed the Exo Urchin. And we also developed the Exo Lodge and Exo Hub. So the Exo Hub is focused on native oysters. So these 4 concepts were further developed during the project, and material testing, computer modeling, and laboratory testing was furthermore carried out. So my main takeaways from the early TRL was that market research has led to numerous nature-inclusive designs, and those nature-inclusive designs are only limited by our imagination, but sadly have to answer to market demand. If there's no demand, then the nature-inclusive designs don't necessarily make it all that way. So market demand is often driven by unit cost and deployment methods, and in contrast, blend design, so the binder design, as well as unit complexity, which drives high cost. So unit complexity often drives biocolonization and species richness, but both drive high cost, which is obviously not good for market demand. And only a small number of target species are prioritized, which we mentioned, whilst there is no international consensus about marine baseline. So these takeaways, I think, are the main takeaways that we had in the years kind of predating the Living Windfarms project. So I've got the pleasure now to hand over to Jack, who's going to cover the middle TRL here. So thank you so much, and I'll close my presentation.
Thank you, William. That's great. I will just share my screen now. And everyone see that okay? Fantastic. Okay, so hi again, everyone. As William mentioned, I will be exploring the middle TRL levels, which focus on design, testing, and prototyping. Of course, there is still research being undertaken as we move into the middle TRL stages, but the focus is more broadly on developing concepts and solutions which have demonstrated potential to meet the market needs. These stages involve considering species preferences, prototyping, and scaled flume experiments, and I will also be touching upon the opportunities presented to us through the use of bespoke design. William has already spoken about material selection and broadly about nature-inclusive design, but it's important to highlight that this only forms part of the consideration. Many of the solutions developed under the Living Windfarms project perform a dual function of scour protection for offshore wind and habitat provision. We therefore need to make sure that by increasing opportunities for biodiversity, that we aren't compromising the functionality of scour protection, and I'll talk about this in a bit more detail shortly. Looking at an ecological function now, though, how can we optimize the design of marine infrastructure to maximize the benefits for biodiversity? As I'm sure most of us will be familiar with, each organism, from phytoplankton to seaweeds to cod, occupy an environmental niche. This is the combination of habitat conditions which are most favourable to the species, and we can think of this as their preference. And there are a number of avenues that we can explore when considering how to design products with species preference in mind. For Exo Engineering, these fall within 3 broad groups, which are conservation evidence, biomimicry, and tender documentation. Now, of course, this doesn't mean that we pick one of the 3 and exclude the others, and these approaches are almost always used simultaneously. So to start off with conservation evidence, deployments which have already been undertaken are a great source of information which can shape new, optimized, nature-inclusive designs. These studies are often, highly scientific and provide us with information on deployment location, the different successes of projects, and key considerations moving forwards. These are all collated on one platform. And we know that knowledge sharing and collaboration is essential for continuing the progression of nature-inclusive design. And another platform that we can use is the Rich North Seas Toolbox. Much like conservation evidence, the toolbox presents a range of projects which have been undertaken to enhance biodiversity and provides us with a quick overview of key things like costs, the different species which have been targeted during the project, and among other important aspects. Another approach we can use is biomimicry, which is an approach that takes inspiration from nature in order to solve human problems. So in this instance, the problem we are seeking to solve, of course, is declining marine biodiversity. As we know, nature is incredibly resilient and often has ways of solving its own problems. In this way, we can have a head start in the design process if we take inspiration from naturally occurring features that we observe to be beneficial for marine life. Although it's important, of course, to consider material composition as well as the types of environment in which these solutions will be deployed. You'll see I've got a couple of examples on the slide here, including kind of surface texture that was inspired by a rock face, as well as a more biogenic inspired texture, incorporating features which mimic barnacles, limpets, and mussels. Another way we can explore species preferences is by looking at the design criteria, which has been explicitly mentioned in offshore wind farm tender documents. We're now seeing increasing numbers of new wind farms actually requiring the deployment of artificial reefs alongside the development of offshore wind farms. And some of these are actually including a specific design criteria for which artificial reefs must adhere to. In fact, this is actually how we produced the design for our Exo units. Tender documentation mandated the inclusion of an artificial reef unit of a certain design. Some of these kind of dimensions are on the slide there. And also included kind of having a large swim-through tunnel and slits to prevent sedimentation in the design criteria. In this example, Atlantic cod and rossworm were identified as target species for the artificial reefs, and then we decided to go one step further and add some surface textures to further increase complexity and bioreceptivity of the unit. Sam, I believe, is going to talk about this in a bit more detail shortly. After this, we come to the prototype stage. So this stage covers a range of aspects such as 3D design, 3D printing, and of course, physical prototyping. If we begin with the 3D design stage, 3D design allows us to kind of visualize our ideas and bring abstract concepts to life, applying the knowledge that we've gained in the lower TRL levels. And it's where ideas really begin to take shape and often involves lots of tweaks before moving on to the next stages of prototyping. We've also got 3D printing, which is an incredibly helpful tool for us, really helpful for kind of visualization as well, and can actually also help our clients if they have kind of 3D printed models. It's a lot easier to communicate designs and ideas through a physical scaled down model. And speaking of scaled down models, we can also use these for flume experiments. Another aspect to prototyping is, of course, actually producing the product, which can provide us with all sorts of information about about aesthetics, how it looks, molding and demolding requirements, and can help to highlight aspects which might have been overseen up to this point. Going back to flume testing, so far we've focused mainly on how we can optimize designs in order to maximize the benefits for nature. But of course, it's equally important to consider how these units behave when they're actually on the sea floor. So for nature inclusive scour protection, it's essential that first and foremost, the anti-scour properties aren't compromised through the introduction of nature inclusive design. And we've got a few different methods that we can use to simulate the behavior of an object on the seafloor especially with regard to kind of the presence of underwater currents. And one of these methods is flume tank experiments. So, in collaboration with the University of Southampton, scaled flume experiments were used to test both our exosphere units and our exolodge units. And during the scaled flume tank experiments using the exospheres, results confirmed that they retained very good anti-scour properties. And you can see this by the fact that there are sand waves kind of before the exospheres, if you imagine the kind of flow of current going from left to right in that right-hand side photo. And after the exospheres, there's not a whole lot of disturbance of the substrate downstream. We can also use computational flow dynamics, or CFD for short, which is effectively computer modeling, which simulates how an object will behave in response to forces acting upon them. In this scenario, it would also be kind of underwater currents and currents with different velocities. And this can kind of, we can use flume experiments to almost validate the findings of the CFDs as well. While the Exolodge units aren't designed to provide scour protection, instead standing to be used as a standalone artificial reef, we still, of course, need to examine how they will behave when they're deployed, which involve determining velocity at which the units would roll, for example, in order to find out a bit more about their stability. Because the last thing that we want is a 4.5-ton artificial reef rolling around on the seafloor. That leads us to bespoke design, which is the final topic I will be covering in the presentation today. So when we speak about bespoke design, you might instantly think of kind of designing an entirely new nature-inclusive unit from scratch. And whilst this is something that Exo Engineering have done quite a few times before, such as with the Exo Lodge in response to the tender documentation, bespoke design can also just refer to tweaking existing designs in order to make sure they are most suitable for a deployment in a chosen environment. Many of us probably agree as well that a one-size-fits-all approach is not optimal across the very diverse range of environments in which we find our offshore infrastructure. And with bespoke design, I think it gives us a real opportunity to optimize biodiversity enhancements. So we've recently begun kind of thinking about ways that we can tweak the Exolodge design to best fit kind of market demands as well. So this has included kind of attaching sacrificial anodes, which help to reduce the corrosion at offshore energy sites. We've also looked into incorporating pre-spattered structures, which support oyster regeneration, and even the addition of trees as well to boost the amount of available habitat for different species to colonize. So following this process, we've been able to develop a range of nature-inclusive units over the course of the Living Windfarms project. All of these had to be designed with conventional deployment methods in mind and to satisfy market demand in order to kind of streamline that process. And they can all be used kind of across different infrastructures associated with offshore winds, cables, landfall protection, and turbine foundations as well. So just to kind of finish up, we've got a few key takeaways here that are kind of pressing as we move forward, thinking about nature-inclusive design. One of which is how can we incorporate bespoke design without significantly increasing costs, risks, and timescales? And I think we know already, but more collaboration is definitely needed, continuing that collaboration as well, which of course the Living Windfarms project in these workshops is helping to do. And the Living Windfarms project as a whole involves kind of cost and knowledge sharing, which we know is really beneficial to advance nature-inclusive designs. Additionally, new technologies such as 3D printing and computational flow dynamics are really helpful for de-risking new technologies, as well as communicating ideas more effectively across different stakeholder groups. And finally, of course, nature inclusive scale protection must retain functionality alongside biodiversity enhancement. This cannot be compromised. Okay, that leads me to the end of my presentation. I will now be handing over to Sam, who is going to talk to us about pilot deployments in a bit more detail.
Thanks very much, Jack. Let me just share my screen. Okay, everyone seeing that? Yeah, wonderful. Okay. Great. Yeah. So I'm Sam. I've been working on the Living Windfarms project, providing monitoring support for our pilot projects, which I'll be discussing today. Just quickly as well, just to mention again that if you have any questions or comments about any of our talks, then do feel free to pop something in the chat and we'll come back to that at the end at the open discussion. So going back to the Living Windfarm Project's TRL levels, I'm going to be covering some of the work we've done towards the later TRLs, discussing some of the work on our nearshore and offshore pilot deployments, which have helped us towards our readiness for real-world commercial deployments. So I'll be focusing on two of our pilots in particular, our nearshore Celtic Sea pilot, which you can see some images from on the top row there, and our offshore pilot in the North Sea shown in the lower images. So firstly, looking at our Celtic Sea pilot, this ran from September 2023 until April 2025. The project was undertaken in partnership with Marine Energy Wales, ORE Catapult and Horizon Energy, and we tested nature-inclusive scale protection solutions in the Marine Energy Test Area, or META, which is off the Pembrokeshire coast in South Wales. This is a pre-consented test site made available for the testing of offshore energy technology, and our solutions were deployed at the nearshore East Pickard Bay site, which sits at approximately 20 meters depth. So we tested various nature-inclusive design concepts for offshore wind scale protection, with over 16 tons of nature-inclusive units deployed at the site. This included our Exo mat, which is a nature-inclusive articulated concrete mattress for cable protection, our Exo reefs, and these are full pipe deployable reef spheres, which form part of the armor layer around monopile foundations. We deployed two of our large Exo lodges, which are purpose-built standalone reef units that we've already briefly discussed. These target specific species and have a sole function to boost biodiversity. And finally, our Exo anchors. These are nature-inclusive sinkers and clump weights, which create reefs as part of mooring systems. And here they were used to anchor scientific monitoring equipment at the site. So I've got a short little clip which shows some of the range of monitoring methods that we use throughout the project. These include using remotely operated vehicles and other underwater video techniques to assess the mobile species using the structures. Sediment sampling techniques were also used, including the taxonomic identification and environmental DNA to assess changes in the species living within the sediments of the sites as well. Because we've just got a very limited time today, I can only give you a very quick overview of some of the results, but from the video data obtained, it does suggest that the ExoLodge standalone artificial reef units may have the potential to provide habitat for a greater richness and abundance of mobile species than either the natural sand habitat or the nearby nearshore natural rocky reef might achieve on their own. In addition to the species recorded using the underwater video techniques, another 21 species were also recorded colonizing the Exo lodges when they were recovered at the end of the project. These included squid eggs, which you can see in the image on the top right there. These were attached to the inside of the large central tunnel. And as well as this, there were juveniles of many other sessile species colonizing the units as well. This suggests that these structures could play their part in providing shelter and habitat that would be needed to allow for a potential nursery ground to develop. Although the site did provide some great results for our exolodges, it proved to be more challenging for many of our other nature inclusive scale protection units because of the environment that it was in. As the substrate consisted of soft sands and the site often experienced strong currents, over time, many of our more low-lying units became buried, which of course meant that their nature-inclusive designs weren't able to provide the optimal habitat that was intended. This goes to show that in some environments, many nature-inclusive designs might not produce optimal results, and it'll be important to marry up the most appropriate nature-inclusive designs with the environmental conditions that are present at the wind farm site. Despite these challenges, that's not to say that these kind of test sites aren't useful. In fact, quite the opposite. Pre-consented test sites such as Meta in South Wales are rare, but being able to use them allows for a significantly reduced timeline from concept to real-world deployment. And the availability of more pre-consented test sites in a variety of different environments would help to better achieve these goals. So next, moving on to our offshore pilot. In collaboration with Total Energies in the Netherlands, 5 of our Exolodge standalone artificial reef units were deployed at 40 meters depth at the base of one of their platforms in the Dutch North Sea in July of 2024. These are being monitored for a minimum of 5 years alongside existing operations, making use of pre-planned maintenance inspections using work-class ROVs at the site. And these include collecting video footage of the units to compare to the existing structure and other controls. And also along with this, recovering smaller removable reef elements from the exolodges to assess the sessile colonizing species that are present. And in addition, environmental DNA techniques are being used to assess changes to the species present over time in comparison to control locations nearby. So 1 year monitoring at the site was undertaken last September. Here's a short clip from some of the ROV surveys that were undertaken. So from these video surveys, the exolodges here, 21 species were recorded in total. We can see here that the different species, there are different species using different design features that are being included, as these design features are creating various habitat niches for species to take advantage of. Crabs and lobsters are using the holes and the crevices of the exolodges, as these were present in much greater numbers than on our control block, which we deployed at the same time, which didn't have any of these same design features. And large numbers of fish, such as these pouting, a smaller relative of the cod, can be seen taking advantage of the small central tunnel here for shelter as well. And on top of the exolodge, you can also see one of our small removable reef plugs. So this reef plug, using the ROV's multi-purpose arm, one of these was removed from the top of one of our exolodges. It was preserved and then sent for laboratory analysis of the species that are present. And from the taxonomic analysis done, a further 43 colonizing species were recorded, including the tube-building ecosystem engineer rossworm, Sabellaria spinulosa, as well as the juveniles of many other species, including worms, sea urchins, sea anemones, bivalves, and many species of crab, including the brown crab that we've already seen making use of the holes in the tunnels and the voids of the exolodges. So even after 1 year, it does appear that the habitat forming design features not only attract species, but potentially also improve the overall productivity of the local ecosystem as well. This highlights the ability to design features to both target certain species and potentially also improve ecosystem functioning overall. So just looking on to our ongoing and future pilot work, the monitoring of the North Sea pilot at Total Energy site will continue in the coming years. And recovered exolodges and exo anchors from our Celtic Sea deployment have been repurposed and used as part of the infrastructure for a multi-use site in the Bristol Channel, which combines aquaculture with seabed restoration, and will be monitoring their effect as part of a larger multi-trophic system going forward. We've also trialled standalone artificial reef units which incorporate elements with remotely set native oysters. And these can be used to help restoration efforts for the species, as well as providing habitat for juvenile fish and other species in a similar way to the exolodges. So finally, just to reiterate a few of the takeaways from my talk. Firstly, a one-size-fits-all approach is unlikely to work in all environments. Some nature-inclusive design options may be less appropriate depending on the substrate and the environmental conditions that are present. Pre-consented test sites should be celebrated, and more should be available to test nature-inclusive design options for wind farms in a variety of different environmental conditions. Some nature-inclusive design options may even provide a biodiversity uplift when compared to natural habitats present locally, and can provide important nursery grounds for juveniles of many species. This may help to speed up the recovery of degraded ecosystems through the reintroduction of hard substrates that were once present. And finally, designing for target species can be optimized by creating bespoke designs which include habitat features that cater to these specific species. In this way, wind farms could create a haven for commercial species like crabs, lobsters, and cod, from which a spillover effect can be created, potentially benefiting local fisheries, as well as boosting biodiversity overall. So thanks very much. That's all from me. Thanks for listening. I'm going to pass now over to Thijs from Total Energies in the Netherlands to discuss some lessons learned and what's next for nature inclusive design in the Netherlands. So I'll just stop sharing. Thank you.
Good afternoon, everybody. I will be telling something about the lessons that we learned from our participation in the Living Wind Farm project and what the next steps for nature inclusive design and Total Energies in the Netherlands will be. So why did we want to have this removable reef block on our exolodges? Because we were really interested in the marine growth of what was developing on these units, because of course one of the target species was Sabellaria spinellosa, the rossworm, and the problem with the traditional method of monitoring these reefs by using, for example, ROV is that cryptic species that hide in the marine growth can't be observed. And also with eDNA, it is sometimes difficult because you know that a species is there, but you don't know if it's on your reef, because Sabellaria also has a pelagic stave. So it could be that you're measuring in your eDNA larvae of Sabellaria. So we wanted to be able to have a scrape sample, but traditionally you would send down a diver with a little scrape and a cup to get some samples. But from safety concerns, we don't allow diving near our platforms. We really try to minimize the amount of diving activities near our platform. So we needed an alternative to obtain these scrape samples. So that's why we asked Exo Engineering to come up with a removable element which can be removed with an ROV. And we were able to do that successfully this summer, as demonstrated here by these pictures. And for us, the main goal of this pilot was indeed to see if we can achieve successful extraction. Of course, from a scientific point of view, there's of course always room for improvement. These reef elements have these edges, these swirls, and that is a slightly different structure than we find on the rest of the exolodges. So that could facilitate a different marine growth. So maybe for a next pilot, it would be better to have a more the same structure as the rest of the unit. And of course, we pulled this through the water column. So we used the ROV hook, and then the ROV was pulled up through the water column. So we could have lost some species. So it would be ideal if this could have been placed in a box, but that is room for future innovation. Sam already mentioned some of the species that we have found. Of course, this is the whole list. To summarize, you had 43 species on this list, 1,500, almost 1,500 individual animals. You can see a lot of barnacles. We have the Sabellaria spinellosa, which is of course an important policy species, and we'll be interested to see if in future years we will keep finding subellaria on this reef, or subellaria is only acting as an early colonizer in the ecological session, and then maybe later on we might not find it. So that will be really interesting to follow if subellaria will be present during the monitoring period. And we got a large amount of these porcelain crabs. We found almost 700 of these tiny crabs. So that was also, I think, very interesting and an indication of how productive this little ecosystem can be. So yeah, what did we? What were the survey results so far? Of course, we don't know the conclusion yet because we had only 1 year of monitoring. So these are just the first impression. But overall, we're happy that the seabed, the excellence have remained stable on the seabed. We saw typical North Sea reef species. The reef plug revival was a success, looking at the species richness, but also from a safety point of view, and also for our logistics, everything went quite well. And what we see from a project management point of view, I feel as for us the pilot was quite valuable. We were able to do it quite fast. Between the first meeting and deployment, it was only about 10 months, and we could really apply learning by doing. Because this was a relatively small pilot, we could really see when we tried to integrate it with our current operations, what went well before committing to a large monitoring project for nature design in other projects. So it really gives us an opportunity to get hands-on experience with nature inclusive design without making a large commitment with. So it was good that we could do that. And yeah, we achieved great synergies between our during the pipeline inspection campaign. We could do the ROV footage, and we could use our walk-to-work vessel to take the eDNA samples. And what I also want to share to my colleagues in industry, I think it's really important that we share these nature inclusive designs results externally, but I also think it's really important to share it internally. When I presented these results to our offshore operators, to the people working in our supply base, they were really enthusiastic, and they had really good questions. They were really interested what species grow on the units, but also what species grow on near our platform. So I got a really good engagement, and I think that's also important with nature inclusive design, is that we tell the story and explain it also to external people, also to our internal people, why we do this. And I think it's important to communicate at all levels of the company that why we undertake such projects. So I think that's also an important takeaway that I wanted to share. But what is next for nature inclusive design for Total Energy Netherlands? Because it doesn't end with this pilot project. In last year, around December, we released this press release that together with RWE, we are co-owners of Oranje Wind Farm, which is in the Netherlands, where we'll be deploying 6 of these Arc Marine reef cubes. So that means that we are also in offshore wind. We will further developing this nature inclusive design and trying to enhance the biodiversity of the scout protection. But we will not only be doing this for offshore wind development, we will also be applying nature inclusive design for carbon capture and storage. Total Energy is part of the Aramis project, which is a large CCS project in the Netherlands, and we will be converting alpha from a gas platform to a CO2 injections. And we will be looking at the following nature inclusive design elements. We will be implementing nature inclusive design matrices. We will be looking at nature inclusive anode support units, as also previously mentioned. Why do we need these anode support units? Well, this jacket has been in the water for 30 years, and the current anodes will not provide protection during the operational phase that is planned for the CO2 injectors. So therefore, we need to add additional anodes, sacrificial anodes, and we think that a nature inclusive design option support unit could be a very interesting option to give biodiversity and a boost. And we will also be looking at tree reefs, because during the stakeholder engagement regarding nature inclusive design, because in the Netherlands it's agreed upon in the North Sea Agreement that all future offshore energy infrastructure must have nature-inclusive design. And during that stakeholder engagement with different NGOs, they were looking for scalability. And together with the NGOs, we came up that tree reefs could be an interesting option for us to deploy. So all the partners involved in the RMS CCX will be deploying these tree reefs. So tree reefs are reefs made of old fruit trees. So fruit trees, they have a lifespan of about 20, 30 years, and then they don't produce enough fruit more. Then they will be taken out and replaced by new trees. And those old trees can be used to make these artificial reefs. And that is why is this an interesting option? First, we want to see if this tree reefs is something where we can achieve scalability. And the biodegradable aspect is interesting because if an artificial reef is truly biodegradable, then we don't have the decommissioning aspect, because the idea is then that the artificial reef that you introduce degrades, and then reforming species can take over and build a natural reef which does not need to be decommissioned at the end of the project lifespan. So we will be supporting that, and to see if it actually works, we also are going to monitor these NID measures. And to have the monitoring, it's also been quite an interesting and challenging process, because if you want to monitor, you must have control units. But of course, control units means that you have less NID units there. So for example, for the mattresses, you need to have a 50-50 splits between the industry standard mattress and the nature-inclusive design mattress. So then it's a bit of a trade-off. You will get results. Will it work or not? But if it works, then you of course have less nature-inclusive design elements there, because it's not possible to replace those mattresses after the monitoring period is over. So that is something of the challenge that we came on during developing this monitoring plan. But we were working together with the RMS partners and a consultant who has done a lot of nature-inclusive design, especially in offshore wind, and with the Dutch Research Institute Wageningen Marine Research. So overall, the story for nature-inclusive design for us in the Netherlands is not over, and it will be continued. And the main goal of our monitoring program will to be answer these research questions. We really want to know if the biodiversity of these NID users is different comparing to the existing infrastructure. We have already a platform there that's been in the water for more than 30 years. So it will be really interesting to know if there is any value to be gained with these specific design units, or is the standard design good enough to have a boost on biodiversity. And of course, we have also sub questions where we look at the species richness, the community of the species, and of course, we always keep an eye on the marine invasive species. So that is what we will do in the future with nature inclusive design. Thank you for your attention, and I will hand the microphone back to Jack.
Thank you, Thijs. Yeah, that was fantastic. Really helpful to get an insight into what's next for the Netherlands and Total Energies as well. Okay, so that leads us nicely on to the next portion of today's workshop, where I will be going through some of the results from the SWOT analysis from the workshops that we did in November. I recognise a few of the names of people who are here today, so I'm sure you're quite eager to see what the results of this were. So for those who did attend the workshops in November, I'm sure you will remember completing a SWOT analysis for each of the 5 nature inclusive concepts which we have on the slides here. These were nature inclusive turbine scour protection, nature inclusive cable scour mattresses, standalone artificial reefs, turbine add-on nurseries, and oyster restoration. We had really good engagement with the SWOT analysis as well, and this provided us with some really helpful insights into the different perceptions of the different groups on these nature inclusive interventions. And so this table gives us a quick overview of the different attitudes between the different groups towards the nature inclusive interventions. So we can see that all stakeholder groups demonstrated favourable attitudes towards the nature inclusive scarab protection, for example, and perhaps unsurprisingly, the ecologists were in support of all of the interventions. The higher amount of uncertainty amongst the contractors and policymakers for some of the interventions might suggest that we need a little bit more collaboration in order to reduce the risks and increase confidence. And of course, it's also important to bear in mind that we had a relatively small sample size for this SWOT analysis. And that's what this SWOT analysis is based upon. So sector-wide perceptions are likely to differ a little bit from this, but it gives us a nice insight. Earlier on, I discussed some of the headline results, but wanted to go into a bit more detail here. So this provides us with a kind of overview of the opinions towards all of the nature inclusive interventions kind of as a whole, in the interest of saving time. But we do have more detailed results, which we hope to share kind of following the workshop today. We published on likely on the Rich North Seas toolbox page. So keep an eye on that if you're interested, and we'll be posting about that on our LinkedIn as well. If you have any thoughts as well, please pop these in chat or unmute yourself to contribute. So let's get started. So some of the similarities in the responses between all of the groups in terms of strengths, all of the groups suggested that scalability was a strength of nature inclusive design within offshore wind, especially for turbine scour protection, mattresses and oyster restoration. Another strength was that it could be integrated with existing infrastructure, particularly as part of scour protection, incorporating habitats within that. It kind of introduces a dual function as opposed to having to introduce an entirely new form of infrastructure. And another one of the strengths that all of the groups suggested was it improves the public perception of offshore wind farms. Moving on to the weaknesses, the complexities associated with decommissioning was something that was suggested, in addition to evidence gaps kind of caused by long-term monitoring campaigns in order to gain kind of an overall idea of biodiversity impacts at a site. And we also had location specificity as another weakness. Not using a one-size-fits-all approach and the need for potentially more bespoke approach to nature inclusive designs. Continuing with the similarities and responses between all of the groups in regards to opportunities, kind of embedding nature inclusive design into future offshore wind farm development. Kind of having this as part of the planning stages and being a key consideration is a real opportunity for nature inclusive design within offshore wind. Additionally, collaboration opportunities between developers, scientists, NGOs, and additionally shared learning, of course, which can lead to better standards of nature inclusive design. And finally, we come on to the threats. I think this is a really prominent threat as well, greenwashing, especially when ecological benefit is unclear. We need to think about how that can be mitigated moving forwards. If we're seeing nature inclusive design being used more widespread in offshore wind farms. Additionally, we've got current policy dependence. Of course, if we see changes in political priorities, nature inclusive design might change in terms of how much it's viewed as a priority. And finally, unintended consequences such as structural instability of existing offshore wind farm infrastructure, as well as ecological imbalance. Now we move across to the key differences in responses between the stakeholders. So with regard to strengths, something that was mentioned almost exclusively by ecologists, we've got kind of biodiversity enhancement, spillover benefits for fisheries, reef effects. Contractors suggesting strengths included compatibility with existing scour designs, as well as standardization and reduced offshore time if we combine with existing operations. And finally, policymakers. We've got alignment with national and EU policy goals, and additionally supports net gain and nature positive commitments. And then when looking at weaknesses, ecologists mentioned, of course, the risk of non-native invasive species and the risks of genetic diversity, specifically in regard to oyster restoration. When we think about weaknesses from contractors, it's things like installation costs, risks and delays, and the compromise of engineering functionality, which is can potentially be increased in the inclusion of nature inclusive design. Finally, policymakers, they suggested some of the weaknesses of nature inclusive design are the unclear responsibilities at the end of life, and difficulty in enforcing non-mandatory measures. I wonder if anyone in the audience is kind of surprised by these results, or if they generally align with what we're expecting. Of course, presenters feel free to chip in as well. Does anyone have anything to add?
Yeah, Jack, just William here. What stands out to me in relation to the weaknesses is that there doesn't seem to be a direct owner of each weakness, or a target group, for example, that could be made into a working group to tackle these weaknesses. There seem to be kind of fairly incidental weaknesses that probably would prove quite hard to overcome, and either got to do with weather risks or, yeah, say for example, non-native invasive species that could be proven quite challenging to manage or control. Anybody else have any thoughts?
Yeah, I think it's also with for us to make nature inclusive design, a lot needs to happen, because we need to communicate with a lot of different departments with their own different priorities. We need to talk during the installation. We have HSC. We're doing inspection. We have to make sure that with doing operational phases, the work can be done. So it takes a very lot of communication for something that maybe currently is not mandatory. This doesn't really help the business case. It doesn't produce more energy. So you really need an internal champion who really pulls who put in the work, so talks to the people. So that's I think also one of the challenges what I see with nature inclusive design.
Yeah, absolutely, and I think that's kind of covered a little bit by the SWOT analysis takeaways that we've got here as well. I think it's really difficult to get the balance right between whether we want something mandated and that kind of being the way forwards. And as we saw in the SWOT analysis, a lot of people didn't think that was the way forward. So, encouraging in the right ways is definitely a key consideration. Some of the kind of headline points from the SWOT analysis and the takeaways that we kind of picked out were a combination of habitat provision with this existing infrastructure being a key strength, which was identified by all. We've also got varying location characteristics, creating challenges for a one-size-fits-all approach. Introducing exactly how we might use bespoke design to kind of solve that problem. We've also got nature inclusive design depending on current policy and susceptible to changes in political priorities. probably quite an important point at the moment. And we've also got differences in priorities between groups, highlighting the continued need for collaboration and knowledge sharing. So I think that covers the SWOT quite nicely. As I say, more detailed results will be published following the workshop as well. I wondered if there were any questions from the audience at this time. If not, we do have a few questions prepared that we thought would be quite interesting to discuss. One of these that I've got here is why are many people in favor of nature inclusive design but don't want it to be mandatory? Is that because we're not too sure of bespoke design considerations, or we're worried that potentially the legislation is going to be too strict and maybe focus on the wrong things? I wonder if anybody had any thoughts on that.
Okay, for me as someone for the industry, first of all, it is if you make it mandatory, then as we see within the Dutch standards, then the Dutch government comes up with criteria of how many gaps, the size. So on the one hand, if you make it mandatory, make it really prescriptive, it limits innovation. So if you are really prescriptive, and what we also see is that it can be really site-specific, which NID solutions will work or work not. So I think it will be very difficult to put it into law or whatever you use as an enforcement mechanism to have something for each site specific, and also for the more complex you make for the business case. Yeah, NID, it doesn't impact the amount of energy that we can produce and sell. So that is also something that, but we still have our the wishes of our stakeholders. We have also .energy, our internal biodiversity commitments that we adhere to. So we have to find and balance this. And I think that for us is then one of the main drivers is indeed that we can see that each site is different, and if we want to have a good solution, then we need to have the freedom to find the right solution for this site and this project, in balance also with, of course, the available budget. And we see, especially with offshore wind, the margins are getting tighter and tighter. So that is my perspective.
Yeah, I definitely. Sorry, go on, William.
Yeah, it's a really, really useful insight. The other angle I've heard is that whose responsibility is it to restore the seabed? And it could be all put onto the developers. If you develop, you have to restore or improve. But in the end, it's a cost question, isn't it? Is the person developing actually responsible for part of the seabed restoration as well? So again, we need a time machine at one point. So somebody get on to that, developing that one.
Exactly, and there's still also merit in sandy habitat. Of course, it has to get a chance to be not disturbed by bottom trawling, but definitely there is merit in to have sandy, especially for sand eel. There are a lot of species who can thrive in sandy beds. So filling the whole North Sea with hard substrate is also not suboptimal. And then you also get into the discussion of invasive species with climate change. When you are increasing the amount of hard substrate, the water temperature, then species range can extend. For example, if we find a species here from Japan, you would say, okay, that's definitely an invasive species. But for example, we saw, I don't know, a while ago, we saw a news and a message pop up that they discovered a pistol shrimp in one of the Dutch wind farms, where the natural range used to be the channel, but now it's found in the Netherlands. Would you call that an invasive species? If we don't know, because of course we didn't know what the past baseline was, but you could argue, well, its range is extending because of climate change, and now because we're building these offshore wind farms, so we get stepping stones where the species can more easily spread themselves out. So I think sometimes the line between what is a natural species and invasive species becomes less clear. So I think that's also a risk.
Yeah, I'll pipe in on that one quickly as well. I definitely agree on that front, and that line becomes a bit blurred, doesn't it? But quite often as well with invasive species, these species become invasive because they're just so good at adapting to new environments. So it's quite difficult to actually to put things in place to prevent that. And we can do what we can about that. There's quite good research out there about where you might find invasive species the most prevalent, maybe in the top few meters, just below the surface, where you might potentially think about what sort of nature inclusive design concepts you would put there. But it's sometimes difficult to completely eradicate that risk. But you would hope that if they're well designed, then the nature inclusive design solutions that you could put in place could help to give the native species a boost, and not just benefit any invasives as well.
Well, it sounds like there's a lot more room for collaboration and also testing. So just emphasising, why the Living Windfarms project has been important for us and our stakeholders, and looking to continue collaborating with everyone, and also talking about the test sites, the meta test site, and even test sites in the Netherlands that are really quite critical as well for development, understanding, and collaboration. Any other kind of positive closing notes there, Jack or Ty, Sam?
I think that's covered things quite well. Sorry, Ty, go on.
Yeah, I think for us it indeed was, I think, a very good project, because it was the first time that we really got our hands on something to do with nature inclusive design. And it's always easier said than done. Oh, we will do the monitoring during our inspection campaign that we're already doing, but we actually we were doing learn by doing. So I think that was a really good opportunity to have a small pilot before we commit ourselves to in a new project, a very large NID project where we have to do some kind of monitoring, that we have some first in-house experience. So I think that was for us really valuable, and I think it also was for our employees was also very good, that they were really exhausted. Often when I bump into people, they ask, do you already have some footage? Do you already have some news on this reef project? So also internally for raising people awareness of what is happening below the water regarding biodiversity, I think it was really a positive impact. And I think that's also not only from biodiversity, but also from awareness. I think it was a really good project for us to participate in, and to provide valuable experience for if we have to do a little bit larger NID deployment for the CCS project, to already have some in-house experience we can build upon.
Yeah, definitely agree with you there, Thijs. Any final thoughts from the audience? If not, I just wanted to say thank you so much to everybody who has attended today. As I mentioned previously, the results from the SWOT analysis will be added to the Rich North Sea website. So moving forwards, to stay up to date with us, give us a follow on LinkedIn, give our project partners a follow as well, and keep an eye out on the Rich North Sea website on their toolbox for the more detailed results from the SWOT. Yeah, I think that's everything. So again, thank you so much for joining today, and we hope to speak to you all soon.
All right, well done, everyone. Thanks so much for contributing.
Thank you.
Thanks, everybody.